line voltage drop. Okay, that okay. So IR is equals to this value. That is clear. I'm just writing here in C. Line, everyone can see, right? I'll just I'm writing here down whatever is being derived. So line drop is equals to IR for a single phase, right? This one. So IR for one conductor. So if it is three conductors, it will be 3 IR. Yes? Is it visible to all?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes. Yes. So I'm slightly adjusting so that it becomes a bigger to see. Yeah. So line drop is equals to 3 into IR for the three phases. So that becomes equal to 3 into the value of IR we just found is rho LJ. Yes or no? Rho LJ. From here we can see it is rho LJ. Correct? Yes or no?
Yes, ma'am.
Yes. So now we'll just find the percentage line drop. So the percentage line drop, I'm writing here as percentage line drop. That is equals to J rho L by V. Okay. Because this is the just the line drop that you are seeing, that 3 into rho Lj. So it will be 3 into rho Lj divided by V into 100. That becomes our percentage, because percentage you are taking out of the total voltage. So J rho L, or 3J rho L, divided by V multiplied by 100%. This will be 100%. It is not being clear, but this is actually 100, it will be. I hope it is clear. Into 100% it should be.
Three.
Space is not more. So 3J rho L divided by V into 100% I've written here. If it is not clear, it is into 100%. Okay. So Let me put.
Excuse me, ma'am, you can extend the page.
Yeah, but my percentage is a bit low here. Percentage of the page setup. Anyway, so up to this you are clear? Percentage drop, line drop.
Tell me, ma'am, once again.
See, up to the 3 row LJ is clear. Line drop equals to 3 into IR. Now in place of IR, I am putting row LJ. Up to this clear?
Yes, ma'am.
So row LJ is the line drop. Now when I am finding the percentage of this line drop, I am putting that fraction out of total voltage, transmission voltage, that is V. So total, if the line drop is J rho L, then percentage line drop becomes J rho L divided by V into 100% or into 100. That is the percentage. So line drop, percentage line drop is the line drop, normal line drop that is calculated above into 100 by V. Hello, anyone can just say whether you are understanding or not.
Yes, ma'am.
So if I find the voltage drop total, still people are joining. Anyway, so total line drop, percentage line drop is this formula. Okay, leave alone the total drop. If I write here as the 3J rho L into 100 by V, it means that line drop is inversely proportional to the voltage, transmission voltage V. V and line drop are inversely proportional to each other. If it is inversely proportional to each other, again, then line drop decreases with increasing voltage, right? This proportionality you understand, I hope. That percentage line drop is inversely proportional to the transmission voltage as per this formula, right?
Yes, ma'am.
So that is the reason if we increase the voltage, the line drop decreases or the percentage line drop decreases. Obviously, provided all other things are constant. Whatever is in the numerator, rho, L, J, these being constant, V is inversely proportional to line drop. So line drop decreases when V or the transmission voltage increases. So here this goes to the third point. The third one, which is no, sorry, the fourth one. Fourth one is the decrease in the voltage drop. Next is the improvement of voltage regulation. This goes the same way because voltage regulation is actually the line voltage, whatever line drop you saw. With that only we calculate the voltage regulation. Just a moment. Till now, line drop is equals to rho Lj that we saw, right? Yes, please respond.
Yes, ma'am.
Yes, ma'am.
So percentage, or rather let me be just percentage line drop. That is basically what I was saying, that it will be in the numerator part, this J rho L divided by V into 100%. This was your formula. Okay. So if percentage line drop is this, the what is actually the meaning of voltage regulation? Voltage regulation is the voltage drop, that is the IR drop divided by the sending end voltage. Okay, basically percentage line drop is the voltage regulation, we can say, without being in percentage. Actually voltage regulation, let me write the formula for you so that you can understand. Okay, voltage regulation is equals to voltage regulation is equals to, in the numerator it will be voltage drop, and in the denominator is it is the sending end voltage. Okay, so this is a fraction. In the upwards it is a voltage drop divided by sending end voltage, which is Vs, or rather V. Okay, whatever the V that you are seeing here, this is the sending end voltage. So voltage drop divided by sending end voltage multiplied by 100, which is exactly equals to line drop. That is our voltage drop and improvement. That is our voltage regulation. Okay, so if it is multiplied by 3 for the three phases, it becomes 3 IR divided by 3, divided by V. Okay, so equals to, I'm writing again here, equals to 3 IR divided by V. Okay, so everyone clear till this?
Yes, ma'am.
Yeah. So
Yes,
voltage
ma'am.
regulation is, yes, voltage regulation is basically voltage drop divided by sending end voltage. That is 3 IR divided by V. Now in place of R, you may place that rho L by A. Then it will be the same thing as I just showed you, because line drop was exactly equal to like this. So I am directly putting this as equals to 3 J rho L by V. I hope it is clear. This J rho L, exactly this thing. Here. Yes or no?
Yes, ma'am.
Right. So 3J rho L divided by V, here goes our voltage regulation. So this is also the voltage regulation. That means it equal to, as J rho and L are constants. So voltage regulation or regulation of the line is improved when the voltage increases. Means with increasing voltage, obviously the voltage regulation will be less. So regulation less means obviously the drop will be less. So that is a good thing, that the sending end voltage will be more near to the receiving end voltage. What we want is that both the voltage will be same. So voltage regulation means that the difference between sending end and receiving end voltage, that basically decreases when V is increased, right? So that is our fifth point from the slide, that decrease in the voltage drop. Okay, so decrease in the voltage drop happens, improvement in the voltage regulation happens. So both the fourth and fifth point is proved with the line drop concept only. Line drop or the line voltage drop is in number fourth one as well as number fifth one. So now what just I did is the voltage regulation, the fifth point. It includes the similar process of voltage line drop. That is the fourth point. So this fourth and fifth point is almost similar. And then it comes the increased power handling capacity, the sixth point. So sixth point is the increased power handling capacity. Power handling capacity is nothing but I'm just writing here again. Power handling, or rather power transmitted, I'm writing power transmitted over a transmission line is given by equals to Vs, which is a sending end voltage, then Vr, receiving end voltage, divided by VSVR divided by X. X is the reactance. If you are not sure, this is the reactance X, because R may be greater or small. So inductance and capacitance can be directly represented as X. So here I represent it as X. So X, Vs VR by X into sine delta. Sine delta. Okay. Now you will ask me what is delta. Delta is the angle between swinging angle or angle between Vs and Vr, we can say. So let alone we, this is just formula which will you will be studying later. So this, just this much you know, because of the power handling capacity we need to demonstrate. So it is related with X and P. Thus, if we assume that Vs and Vr is equal, suppose sending end and receiving end voltage is equal, then the power transmitted, that is P, power transmitted over the line, is actually proportional to square of the two voltages. Means if Vs or Vr we consider equal, then Vs Vr becomes, suppose, V square. V square by X into sine delta. This means that it increases, means with increasing voltage the power handling capacity increases. If V square is the relationship proportional with the power P, then V square proportional to P means as V increases, P will directly increase. So this means if the power transmitted is proportional to the square of the voltage, and as the voltage increases, the power handling capacity of the line also increases. Is it clear?
Yes, ma'am.
Yes, ma'am.
Okay. So these formulas are very important. It will be good for you if you note down the formulas, at least the formulas, nothing else. So that is why I told you to sit with the pen and paper. Okay. So this thing is done. Next, whatever the expressions or whatever the points of the advantages of high voltages are. For example, the increasing transmission efficiency, total line cost per megawatt. These are the things that are general. That is no relation is held in this. Yes, transmission efficiency has a certain formula. Except for that, anyone has any idea or any do you know about the relation between uh, what the formula of any kind of efficiency can be? Formula for efficiency, anyone? What is efficiency of anything represented as? Efficiency of anything is represented as what? Am I audible to you?
Yes, ma'am. Audible, ma'am.
Represented as what? Very easy, you know that.
Ratio of output, ma'am.
Correct. Ratio of output and what?
And total input.
Output divided by input. That is efficiency of anything. Yes, correct. So, efficiency here in the seventh point, you see increasing transmission efficiency, they are saying. So, transmission efficiency is given as line efficiency because it is the transmission line. So, transmission efficiency or the line efficiency is actually given by output divided by input, and it has a certain derivation of formula also. So, output by input goes basically as output power and the input powers expression. That's it. So basically we determine the output powers expression, we determine the input powers expression, and we find the line efficiency. It is a similar one, easy one. I am not deriving it because it is taking time of derivation. So I am, in short, I am telling you that whenever you see efficiency, this transmission efficiency, this means basically output divided by input. So output's expression means output power divided by input power. Whatever the term that you get by dividing, that is your efficiency equals to that term. So that term also shows that line efficiency is higher for higher transmission voltages, because in all the expressions, if you see, voltage comes in the denominator. If you equate, then the parameter you are talking about, suppose line drop, voltage regulation, current losses, all these v comes in the denominator. That means inversely proportional. So that is the thing. Every parameter we are showing it that it is inversely proportional to V, and hence the line efficiency is higher for higher transmission voltages. Obviously, provided constant values of rho, L, J, all other parameters. Is it clear whatever I am telling? Understanding or not? Hello? Is it clear?
Yes, ma'am.
Hmm. Okay. Yes. So these are the advantages. Why I am explaining you this detail? Because you see, whenever the question is coming in the exam, they will not just tell you to write the advantages and you write these points and you'll get marks. It's not like that. Okay, means it is in the examination, it often comes, why is the transmission carried out in high voltage, or what are the advantages of high voltage transmission. So these are the reasons why it is carried out, these are the advantages why it is carried out at high voltage. So these advantages you have to explain with parameter wise formulas or terms, how it is coming, how it is getting derived, this thing. So till this all the derivations are clear, I hope everyone.
Yes, ma'am. Clear, ma'am.
Okay, okay.
Yes,
So
ma'am.
now we are moving on to the normal last three part, last three, 8, 9, 10, whatever you are seeing in this slide. Eighth point says that the total line cost per megawatt per kilometer decreases with increasing line voltage. Obviously the cost will be decreasing with increasing voltage. If the conductor material is low, if the power handling capacity is high, and all other factors whatever we derived, so obviously the line cost per megawatt per kilometer will decrease with increasing line voltage. So that is again one advantage. And the last two advantages says that the number of circuits and the land requirement also reduces if you transmit in high voltage. If transmission happens to be in the high voltage, then the number of circuit and the land requirement also reduces. And the last point is operation with high AC voltage is simple and reliable. It is very reliable. Basically a robust system whenever it is carried on at high voltage. And that is the reason always transmission takes place at high voltage. So I think enough of this advantage of high voltage. We'll move on to the next one. That is the disadvantage part. Okay, so the disadvantages part is relatively low, and we do not count for that. Still, what can be the high voltage problems? Those are the problems of high voltage transmission or the disadvantages. Those are what? The first one, corona loss and interference increases. Line supports need extra amount of metal. Erection difficulties means when you are building it, erecting it, then erection difficulties for high voltage lines. Then comes the insulation, because as you increase the voltage, insulation problem starts. So insulation means very good insulation is needed. A proper, well protected insulation is needed. So insulation needs is the next one disadvantage. Next is the increase in cost of equipments. The cost increases because it is at high voltage, so very high cost, very robust materials are required. And next is the high voltage lines that generate the electrostatic effects. So these are the disadvantages, but rather than disadvantages, advantages only come more in the exam part. So advantages, disadvantages of high voltage transmission. Now, what else can be transmission processes? Obviously, it takes place at high voltage. Next is the choice of current you are delivering. So the choice is upon you that you will choose AC or DC. So for AC or DC to choose, there are again advantages and disadvantages. So for AC system, we see that the cost of the AC generation is very low, and compared to the DC, it is better. Means cost wise, AC system is low compared to DC. Next advantage in AC system that we have is that with the advent of transformers, remember transformers, these transformers are purely AC devices, AC apparatus it turns. It doesn't run on DC. It may run, but it will be causing high effect of saturation and it does not do any good. So transformers are purely AC instruments or purely AC apparatus. Now, with the advantage of transformers that we can get in AC, obviously we can say that with the advent of transformers, AC voltage can be raised or lowered to any desired value. So if you got to run the transformer, means to raise or lower the voltage, then obviously you have to go with AC. Okay. Now, if you go with DC, what is the problem? You will have to connect a rectifier and inverter at the two ends while you are input of the transformer, output of the transformer, because it is DC. So DC to AC you have to make it. Then again AC to DC you have to make it. So these problems will be there if you connect DC. You cannot use transformers without the use of rectifiers and inverters. Next is the maintenance of AC substation. That is very easy, relatively easier than DC, the maintenance. And the last point of the advantage is that the motors running on AC system are simple in construction, low cost, and decreases the cost of maintenance. So motors that run, they basically run in AC and are simple. The motors that run in AC are simple in construction and low in cost. So that is why it is better to use AC. Now we come to the disadvantages. So disadvantage part is, we can see it is more than the advantage part. So we'll see in the disadvantage part. First thing is that the construction of AC transmission line is more complicated than a DC. So construction wise, AC transmission line is complicated. Next is that the voltage drop in AC lines is large because of inductance effect of the line. That means the voltage drop that we were just calculating, that voltage drop in AC lines is very high due to inductance, presence of inductance. You see, in DC, we do not have the problems of inductance and capacitance. It is present in AC only, inductance and capacitance. That is why the voltage drop that becomes large in AC lines due to inductance. Next is that the copper requirement of AC line is more compared to DC. So you see in AC line, the copper requirement, that means the volume of the conductor material that I was saying, the amount of copper spent on that cross section of the line. For that, the copper requirement of AC line is more compared to DC system, because obviously three phases are going. So 3 into IR means three times the copper requirement increases. Okay, so that is why in AC it is almost thrice than in DC. Okay, so next is that the AC transmission lines experience corona and corona loss. Corona is an event, is a phenomenon in case of, means this term corona, don't get it confused with any biological term. Okay, corona is basically a phenomenon in electrical power system due to which a huge amount of loss occurs. Why it occurs, we will have it later because it is in the second module. We'll go step by step. So corona is an event due to which huge amount of loss takes place, and corona happens in AC only. In DC there is no such corona problem. Okay. Then it is said that in AC system the generation of the, means in the generation part the synchronization is required. Very important, the synchronization means RYB, if the three phase is there, or simply the generators are connected one after another, that synchronization, that maintaining that in AC is very important, and that is why it is a disadvantages in case of AC, that the synchronization is a necessary thing. So that is one disadvantage again. And the last point is that the charging current exists when the line is open because of the shunt capacitance. This also we will study later. Charging current exists in the lines. When the transmission lines are carrying current, they are carrying it over huge distances, means very far away from each other. So that in that very means long distance, what happens? The lines start behaving, means suppose two lines or three lines are there, they start behaving as capacitors. Now, what do capacitors do? Capacitors store charge. Now, by storing charge, it continues in very long distances. What happens? Receiving end voltage becomes more than the sending end voltage. So that is another effect. I'll say that later. That effect comes into play, and that is called as the charging current. So the charging current exists even when the line is open because of shunt capacitance between the lines and the line and neutral. So these are the disadvantage part. So advantages and disadvantages when transmission takes place in AC system, and a replacement is, or a solution to this problems is DC system. So DC system, as you can see, there are advantages mainly that are overcome. Means in the AC system, whatever problems were there, those are overcome in the DC system. Hence, what happens in DC? The cost of the conductor material obviously reduces because in AC it is three phase, so three wires were used. In DC, only two conductors or two wires, because line and neutral, only two. Okay, so this is the first advantage. Second is that in DC system, there is no inductance, no capacitance. as I was saying, in AC, due to inductance capacitance, there are a lot of problems started there. So for AC, that solution is in DC, where in DC system there is no inductance and capacitance, and so the voltage drop and the power loss is also much lower compared to AC. Third point says that because of low voltage drop and low power loss, the voltage regulation improves and the transmission efficiency increases. So, you know that voltage drop, as I was discussing, line voltage drop or line drop, due to that, the voltage regulation also becomes poor if there is huge voltage drop. Okay, so that is improved, and transmission efficiency is also increased because they are related to each other. So regulation is improved and transmission efficiency is increased if we use the DC system. Then comes that as the operating voltage in DC, there is DC, then there is no skin effect. Skin effect is another effect. You see all these effects, corona, skin effect, Ferranti effect, all the effects that you see, these are all very important issues, power system or transmission and distribution. So keep them in mind. This will be discussed later. Skin effect is another effect that is introduced when we use AC. Okay, so skin effect is not there if we use in DC, and so the resistance of the conductor is also low. Next is that for the same voltage level, same voltage, okay, the voltage stress on the insulation is less in DC system. So the insulation required is less in case of DC when compared to AC. So voltage stress also decreases, means whenever you are using insulation, because it is very high voltage, so very high insulation should be used. So that insulation, how much stress it is facing due to that high voltage, that is the stress, voltage stress on the insulation, that is much less in DC rather than in AC. Okay, so these are advantages and disadvantages of DC and AC system, very, very, very important. Next, we will move on to what are the different types of transmission. Types means how are the transmission systems carried on. There are two kinds of systems, overhead and underground. Very, very important because our first 2 to 3 modules, those first 2 3 modules are um, about only overhead system, overhead transmission lines, and the last 1 or 2 modules, it is about underground cables or the underground system. You see, whenever we are going to overhead system, we use overhead transmission lines. This is one type of transmission. Another type is underground cables, using underground cables, that is in the underground system. Okay, so in overhead system, what happens? The electrical power is transmitted using overhead transmission lines that goes in the upwards in the air. You see, when it is being transmitted, you can follow it up at very large distances, as I was saying in the previous class. So that is overhead transmission lines that go over very long distances. In such type of system, that is overhead transmission line system, the appropriate spacing is provided between the conductors at the supports and intermediate points, and this spacing provide the insulation which avoids the electric discharge to occur between the conductors. So this is the overhead transmission line system. The main thing advantage I can say is that it is cheaper than underground system, and in case of any fault, you can see clearly because it is above the ground, right? So you can see clearly if any fault or short circuit, they can be easily repaired. But in underground cables, it is just underground, means totally below the soil, very far away below the soil. So it is difficult in case of any short circuits to repair them, underground cables. Okay, now the what is underground system, how they are done? Underground system are mainly done by laying of cables in trenches. So first trenches are built, in inside which the cables are given. Cables are very finely insulated. Insulation is very important. So that goes below the soil, underground transmission system. So the cables are generally preferred in underground system, and the cables inside the cables are the conductors. So all conductors must be insulated from each other in the underground system. And as the voltage level is high, the insulation required in the cable is more. Hence, due to the insulation difficulties, the voltage level used in underground system is below 66 kV, not a very high voltage. 66 kV is okay, means moderate high voltage. So the maintenance cost of the underground system is low. And what is another advantage? It is that whenever surges, anyone heard the term surge? Surges, what is the meaning of surge? Anyone? Meaning of surge?
Increase.
Right, increase. Means surge actually means a sudden jump, means a sudden increase, huge increase. Okay, that sudden huge increase occurs. What occurs? The surge of over voltage or sudden increase in current. That due to that, what happens? The insulation failure occurs, or it can cause certain obviously transients to flow. So these are the surges that one should be aware of while doing the underground cable work. So the line surges are suppressed if we used underground system. Means those surges are generally, so for example of a surge, for example, okay, I'm giving an example. Lightning. Lightning can cause a surge. Okay, that surge can affect obviously first the cable, then the conductor. Now, insulation must be very proper so that proper protection is given for this surge. So that is why if we lay it underground, it is automatically suppressed. The surges are automatically suppressed by using the cables, and hence the cables must be used for the last part of the connection, which is, for example, transformers and generators. It can save them, means laying the cables can save the transformers and generators from the damage that can be caused due to the line surges. So if in case of underground cables, the transformers and generators can be saved from the surges and the damage due to the line surges. So this is the main difference between overhead system and the underground system. um, Next, I'll discuss in the next class. It is already 2 o'clock, so I'll be finishing this off. And I hope everyone has written the expressions, because I'll be seeing the expressions, your copies once the college opens. I'll see that. Next is I'll share everything once the module is completed. So I'll finish this module and then I'll send the notes, the PPT first, and then the notes. Okay. So questions? Yes, Domini. Any question?
No, madam.
Okay. Anyone has any questions? Okay, fine. So I'm just putting an end to the class. I have already noted, because it is on record. I know who have joined. Attendance is taken. Thank you, everyone. You can leave the class.